So first, special products. So what we mean by special products is technically there is a formula you can use to multiply these out. But after several years of trying to do it that way, I've found most people like to just stick with the box. So I will show you both ways and let you decide. Alright, so the first one is a square of a binomial pattern. What that means is we have something like this. 3x plus 4 squared. Now all that really means is this. 3x plus 4 times 3x plus 4. So you could stick with using the box if you'd like to do that. On these, I actually prefer to do that up for the next type, a little different. The next type, the shortcut's a little easier. Okay, if you're going to use the formula, and I'll leave these up on the board, I haven't written them up there yet. All it is A stands for first term, B stands for the second term. Square the first term plus, then you do 2 times the first times the second plus square the last term. The only difference is if instead of a plus it's a minus, it changes that first sign to a minus. To me, that's a lot to remember as far as a formula that's supposed to make it easier. Okay, but if you do it that way, it would look like this. Square the first term, which would be 3x squared, plus 2 times the first term, so times 3x, times the second term, which is 4, and then plus the second term squared, so 4 squared. These boxes are a little small, so we're going to do every other one. So if you want to kind of draw a line through B, we're going to skip that. Okay, from there, you would just simplify that. We would need to do 3 squared, which is 9, and then x squared. And then if we multiply these together, what's 2 times 3? 6. 6 times 4. 6 times 4? 24, there we go. And then 4 squared would be 16. So there would be your answer. Okay, I'm going to show you what it would look like if we just stuck with using the box. And you can decide which way seems easier to you. So if we take that problem, the key is just remembering when it's written like that, it just means the same thing twice. So you're going to put 3x plus 4 on the top and down the side. Okay, so what would the first box be? 3x times 3x. 9x squared, which you notice is the same thing we got here. 4 times 3x. 12x. 4 times 3x again. 12x. And then last, 4 times 4, 16. And if you combine 12x and 12x, you get 24x in the middle. Okay, so it's going to give you the same answer. It's just kind of what you prefer. Okay, like I said, most people usually end up sticking with the box on these. Alright, let's look at C. We'll do it both ways again, just so you can see it both ways. So first term squared plus, because it's a plus sign, 2 times the first term, so times 2x, times the second term, which is 1. Then plus the second term squared, so plus 1 squared. And then we would simplify that. So 2 squared would be 4. Then you got x squared. Plus, what's 2 times 2? 4. So 4x times 1 is not going to change it. And then last, plus 1 squared, which is 1. Okay, so there'd be our answer. Let's use the space right below it. So cross off F to see it with the box. So 2x plus 1 times 2x plus 1. Okay, so 2x times 2x. 4x squared. Good, same thing we got there. 2x times 1, 2x. Same thing here, 2x times 1 is 2x. And then your last box, 1 times 1 gives you 1. So here was your like terms, and you end up with the exact same thing. Okay, the reason why we have that formula is this. If you look at what they're doing in the formula, in the middle term, we're doing 2 times the first term times the second term. Well, the reason why that is look at what happened in all these boxes. Those like terms that we're combining, they're the same, right? Same thing here. So we're just doing 2 times one of those to get the middle term. That's what that formula is trying to do for you. Make sense? If you don't like it, stick with the box. All right, let's do one more, both ways. So let's cross off E, we'll do D. Okay, so square the first term, so 3m squared. The plus sign again, so we bring down the plus sign. 2 times the first term times the second term, so times 3m times n plus the second term squared, so plus n squared. So simplifying that, for that first term, what is 3 squared? 9, so it becomes 9m squared. Middle term, 2 times 3? 6, and then you have m n. And then your last term, can't simplify n squared, so we just bring down n squared. So there'd be your answer. Bless you. Okay, so looking at this one with the box, we have 3m plus n on both sides. Okay, so top left, 3m times 3m. 9m squared, right? Same thing we got there. 3m times n. 3mn. Same thing here. 3mn, and then your last box, n times n squared. So here was your like terms. And 3 plus 3 gives us the 6mn in the middle. So it works out to be the same. All right, any questions on those? All right, so move over to the other side, and this one's slightly different. All right, these are when you're going to have, you'll have 2 sets of parentheses. It'll be the same numbers and different signs, like t plus 5 times t minus 5. Okay, let's work this using the box so you can see what's going to happen, and it explains where the formula comes from. So t plus 5 times t minus 5. Okay, so what would that first box be? T times t. T squared, yes. 5 times t. 5t. Negative 5 times t. Negative 5t. And negative 5 times negative 5. Negative 25. All right, so what's going to happen with my like terms here? 5 minus 5. They cancel each other out, right? That's what's going to happen on every single one of these. So all you end up with is the first term squared minus the second term squared. So it turns into t squared minus 25. Okay, so anytime we see same terms, one's plus, one's minus, all you really have to do is square the first term. So I'm looking at h here, x squared. It's always going to be a minus. And then square the last term. So what is 10 squared? 100. So there it is. Okay, and that's happening because on every single one of those, that middle term is going to cancel out. Like here, if we had done the box, we'd ended up with negative 10x and positive 10x on those 2 middle boxes. And they would cancel. Okay, the reason why it's always a minus is look at your last term. That's always going to be a positive times a negative, right? So it's always going to be a minus there. That sign will never change. So if we use that again, on I, square the first term, minus square the second term. And then you just simplify that. What is 2 squared? 4, so you get 4x squared, and then 1 squared is 1. Okay, but once again, if you prefer to just stick with using the box and cancel out those middle 2 boxes, there's nothing wrong with that. It works that way also. This one does save you a little time, though, if you like to use that little shortcut. Let's do 2 more of these. Okay, so square the first term. So this would be 3x squared minus square the second term. The key is when you simplify this now, make sure you square the 3 and the x. So what is 3 squared? 3 squared, 9. So 9x squared, and then we can't simplify anything with the y squared, so just bring it down. there. Okay, so a big part of it is being able to recognize which type is which. This one, where you can square the first minus square the second term, is when you have two sets of parentheses, one's a plus, one's a minus. This other one was when you only had one set of parentheses squared. That's where you could do the box and put the same thing on the top and the side. Okay, so what I want y'all to do is flip it over. I'll give you two of each type, and we'll check them, then we'll move on to the next part, the composite and shaded areas. So do 1, 2, 4, and 5. 1 and 2 are like the first ones we did. 4 and 5 are like the second ones we did.